On the morning of June 6th, 1944, German observers peering through the concrete slits of the Atlantic Wall saw a nightmare on the horizon. Thousands of ships carrying landing craft, tanks, and a massive combat force. The Wehrmacht braced for a brutal, conventional fight, but they were fundamentally wrong about what was actually crossing the English Channel. America's real weapon wasn't even ashore yet. It was an invisible, relentless network of cargo holds, repair workshops, and transport columns, originating in factories 5,000 kilometers away. Germany prepared to defeat an army, but an entire industrial system had arrived. For years, the German High Command calculated coastal defense through simple, rigid mathematics. Divisions, artillery batteries, and concrete bunkers. Their staff officers believed that even if an Allied force managed to claw its way onto the French shore, the offensive would inevitably choke on its own requirements. Without a captured deepwater port to continuously unload heavy munitions, replacement engines, and thousands of tons of daily fuel, any invading army would starve within days. Yet, as the battle for Europe unfolded, that mathematical certainty collapsed. At what point did seasoned German generals realize they were no longer fighting a conventional military force, but an entire industrialized continent transplanted directly onto the sands of Normandy? How could an army be defeated when its combat power was not measured merely by the battalions on the front line, but by an endless conveyor belt of steel operating across the Atlantic? Every manual, traditional military doctrine dictated that an advancing army eventually exhausts its momentum. What arrived in France defied every European rule of operational warfare. To understand the sheer psychological shock that paralyzed German command bunkers, we first have to examine the bedrock logic of their coastal wall and the fatal assumption upon which the Third Reich staked its survival. The fatal assumption was rooted in the fundamental laws of military physics. By early 1944, the German High Command, the OKW, possessed a remarkably accurate understanding of what it took to sustain a modern, mechanized offensive. They knew that a mid-20th century army was essentially a massive, moving, industrial city that produced nothing and consumed everything at a terrifying rate. To merely maintain its combat effectiveness, a single American armored division required over 600 tons of supplies every single day. When multiplied across a multi-army invasion force involving hundreds of thousands of men, the daily logistical requirements skyrocketed into the tens of thousands of tons. In the minds of seasoned German strategists like Field Marshal Gerd von Rundstedt, there was only one physical way to move that staggering volume of steel, fuel, and explosives from the sea onto dry land. A major deep-water port. Not a sandy beach, not a tiny fishing village, but a massive industrialized harbor equipped with miles of concrete docks, heavy mechanical gantry cranes, and direct, deep-draft railway access. Cherbourg, Le Havre, Calais, Antwerp. These were the only geographical points on the map where a true, sustained invasion could survive. An open beach, by contrast, is a logistical death trap. The Normandy coastline, with its shallow gradients and extreme tidal shifts, was viewed by German planners as a natural quarantine zone. The English Channel is notorious for volatile, unpredictable weather, and the tidal range off the French coast can expose or submerge hundreds of yards of wet sand in a matter of hours. You cannot dock a 10,000-ton Liberty ship on a sloping, sandy shore. You cannot rapidly unload heavy locomotives, replacement tank engines, and bulk artillery shells by hoisting them over the side into small boats and carrying them through the pounding surf by hand. Even if an initial assault wave managed to storm the beaches and secure a shallow foothold, the German staff officers calculated that the geography itself would quickly strangle them. The invaders would be forced to rely on a precarious fleet of flat-bottomed landing craft, constantly shuttling back and forth from massive transport ships riding at anchor miles offshore. This process was so painfully slow, so inefficient, and so highly vulnerable to the slightest storm that it could never sustain a prolonged continental offensive. Because this logistical arithmetic was considered absolute, the German defensive strategy was built entirely around it. Adolf Hitler issued standing orders designating major French coastal cities as Festungen, fortresses. They were to be heavily garrisoned, fortified with thick, reinforced concrete, defended by massive coastal artillery batteries, and held to the last man. But the strategy was also brutally pragmatic in its scorched earth logic. If the Allies attacked a major port directly, they would be bled white in a frontal assault against impregnable defenses. If they instead chose to land on open beaches and attempt to capture a port from the rear, the German garrisons were under strict orders to systematically destroy the harbor facilities before surrendering. At Cherbourg, the primary deep-water target near Normandy, German engineers prepared to detonate thousands of pounds of explosives to shatter the breakwaters, collapse the piers, and sink block ships in the deep channels, guaranteeing the harbor would be utterly useless to the Americans for months. The German command knew they did not necessarily have to push the Allies back into the sea on the very first day. They merely had to contain the beachhead and let the iron laws of logistics do the killing. The Wehrmacht anticipated a highly predictable, mathematically certain timeline. Day 1. The Allies stormed the sand, taking heavy casualties but establishing a perimeter. Day 3. The Allied footprint expands, but their stockpiles of ammunition and fuel begin to dwindle rapidly as frontline consumption drastically outpaces the slow, agonizing trickle of supplies coming in over the beaches. Day 7. The critical breaking point. With no captured deep-water port functioning and the beach logistics inevitably hampered by the choppy channel weather, the Allied war machine would begin to suffocate. Sherman tanks would run dry and become static pillboxes. Artillery batteries would fall silent, forced to conserve their last remaining high-explosive shells. Replacement parts for broken-down vehicles would be stuck out of reach, deep inside the cargo holds of transport ships, pitching in the waves miles out to sea. The invasion force would become a stranded, immobile whale, suffocating under its own immense weight. This was the precise moment the German High Command planned to unleash their heavy armored reserves. Panzer divisions, deliberately held back from the immediate coastal fighting, would be ordered forward to crush a paralyzed, desperate enemy. They would not be fighting a fully supplied, highly mobile American army. They would be executing a mechanized slaughter of infantry and armor that had literally run out of the basic materials of war. The German defensive matrix was not built on the naive assumption that the concrete Atlantic wall could never be breached. It was built on the absolute certainty that a breached wall meant nothing if the enemy starved to death in sand. Every war game, every high-level staff meeting, and every defensive blueprint in Berlin relied on this fundamental geographic reality. It was a strategy grounded in centuries of European military doctrine. You simply cannot move mountains of steel without a harbor. The German logic was mathematically sound. It was deeply realistic. It was grounded in the undeniable facts of the terrain, the weather, and the sheer, staggering tonnage required to feed a modern mechanized war machine. By every known rule of traditional warfare, an invasion over open beaches was an operational dead end. And that calculation was entirely correct, right up until the moment the Allies simply decided to rewrite the rules of geography. If the fundamental law of European warfare dictated that an invading army must capture a deep-water port to survive, the Allied command made a staggeringly audacious decision. They simply built their own and towed them across the sea. The plan was codenamed Mulberry, and it delivered the first shattering blow to German operational logic. While Wehrmacht commanders confidently waited for the inevitable logistical strangulation of the Normandy beachhead, British and American engineers were already assembling two massive artificial harbors right off the French coast. This was not merely an emergency resupply effort. It was a direct, physical countermeasure to every tactical expectation held by the German High Command. Berlin calculated that the volatile English Channel would severely disrupt the continuous unloading of fragile, flat-bottomed landing craft. In response, the Allies sank dozens of obsolete warships and massive, hollow concrete blocks, each the size of a 6-story apartment building, directly into the ocean floor, instantly creating miles of artificial breakwaters. These structures absorbed the violent surf, turning the deadly coastal waters into a placid, functioning harbor. German strategists relied on the extreme tidal shifts of the French coast to prevent heavy transport ships from docking. The Allies countered with towering steel pierheads designed to float, sliding up and down on heavy spud legs to perfectly match the surging tides. Cargo could now be unloaded 24 hours a day, completely ignoring the water level. German intelligence assumed that without permanent stone docks, 30-ton tanks and railway locomotives could never reach the sand. The Allies answered by unspooling miles of flexible, floating steel roadways, connecting the deep-water pierheads directly to the beaches. When Luftwaffe reconnaissance pilots finally managed to slip through the Allied fighter screen to photograph the Normandy coast, the images they brought back defied military comprehension. They did not show a starving, stranded army desperately ferrying wooden crates through the surf. They showed a synthetic, industrial metropolis that had literally appeared out of nowhere. Huge transport ships were unloading directly onto steel highways floating on the ocean. Every geographical barrier the German staff officers had relied upon to kill the invasion was met with an immediate engineering solution. If a tank broke down, it wasn't abandoned to rust in the surf. It was recovered and repaired. If the ocean threatened to wash away a supply dump, earth-moving equipment carved out new staging areas inland. The impenetrable coastal quarantine zone had been entirely neutralized. By the end of June, these artificial harbors were funneling thousands of tons of vehicles, fuel, and ammunition onto French soil every single day. The beachhead was definitively secure, well-fed, and heavily armored. But as the Allied armies finally prepared to break out of the coastal sands and plunge deep into the French interior, they were about to trigger a completely different kind of logistical nightmare, one that no artificial harbor in the world could solve. But before that inland nightmare could materialize, the German High Command was handed what looked like a miraculous reprieve by the atmosphere itself. On June 19th, 1944, the worst summer gale to hit the English Channel in 40 years slammed into the Normandy coast. For 3 relentless days, force 8 winds and towering violent waves battered the invasion beaches. Inside their command bunkers, German meteorologists and staff officers tracked the low-pressure system with absolute grim satisfaction. The English Channel was finally doing what the Wehrmacht's coastal batteries could not. At Omaha Beach, the American artificial harbor, Mulberry A, was being systematically torn to pieces by the sea. The massive 6-story concrete caissons that formed the breakwater began to crack and shift under the immense kinetic force of the waves. Floating steel roadways snapped their moorings, twisting into jagged, useless scrap metal. Heavy steel pontoon sections broke loose and acted like unguided battering rams, smashing through the remaining piers. By the time the skies finally cleared on June 22nd, the American deepwater port was an unrecognizable field of floating debris. The German operational calculation at this moment was straightforward and highly optimistic. By their rigid logistical mathematics, the American supply line had just been severed. The artificial harbor was dead, which meant the continuous flow of heavy armor, artillery shells, and aviation fuel was choked off. The hundreds of thousands of American troops already on shore would rapidly burn through their localized reserves. Without a functioning port to replenish them, the invasion force would begin to starve, perfectly setting the stage for a massive German armored counterattack to sweep them back into the sea. But the German command fundamentally failed to account for American mechanical improvisation. They expected the United States Army to pause, to desperately attempt to rebuild the ruined steel piers, and to halt offensive operations while they waited for the weather to stabilize. The Americans did none of these things. Instead, they completely abandoned the rigid European doctrine of deep-water docking and embraced a chaotic, brute force alternative. Major General John C. H. Lee's logistical network simply adapted in real time. Rather than attempting to ferry cargo delicately to the surviving piers, the Americans ordered their massive 300-foot-long LSTs, landing ship tanks, to drive at full speed directly onto the sloping Normandy sand on a falling tide. The ships were deliberately and violently grounded. As the ocean receded, leaving the massive vessels stranded on the wet beach, their massive bow doors swung open, and thousands of heavily loaded transport trucks simply drove out of the holds and straight up onto the French mainland. Simultaneously, the Americans stripped the hopelessly wrecked Mulberry A for salvageable parts to reinforce the surviving British harbor at Gold Beach, and then mobilized an absolute swarm of DUKWs, 2.5-ton amphibious trucks. These hybrid vehicles swam out through the turbulent surf, pulled alongside deep-draft Liberty ships anchored miles offshore, loaded cargo directly from the ship's cranes while bobbing in the open ocean, and then drove straight out of the water, across the sand, and directly to the frontline supply dumps without ever stopping to unload at a dock. The result utterly defied German military logic. On the first clear day after a devastating storm that had completely destroyed their primary harbor facility, utilizing nothing but bare sand, shattered steel, and relentless organizational momentum, the Americans actually unloaded more total tonnage than they had when the artificial harbor was fully intact. The weather could not starve them. Realizing that the beachhead could not be sealed by the ocean, the Wehrmacht immediately shifted to its next deeply ingrained tactical doctrine, the fighting retreat. As American forces began to slowly push inland toward the deep rivers and flooded marshes of the Cotentin Peninsula, German pioneer battalions executed a ruthless, highly systematic, scorched earth policy. They rigged and detonated every stone arch, every steel truss, and every railway viaduct spanning the Douve, the Veer, and the Orne rivers. In traditional European warfare, a destroyed bridge over a deep, muddy river meant an immediate operational delay of weeks. It required halting the armored columns, bringing up massive timber reserves, deploying heavy steam-powered pile drivers to sink wooden supports into the riverbed, and utilizing highly specialized engineering labor to construct a crossing capable of supporting the sheer weight of 30-ton tanks. German commanders expertly positioned their deadly 88mm anti-tank guns on the opposite banks and waited, fully expecting the American offensive to grind to a total halt while their engineers scrambled for wooden beams and concrete. Instead, the Wehrmacht was introduced to a piece of modular British engineering that had been aggressively mass-produced by American industrial manufacturing, the Bailey Bridge. Within hours of an American armored column reaching a smoking, demolished river crossing, specialized combat engineer battalions would arrive in convoys of standard transport trucks. They did not bring raw timber, cement, or heavy construction cranes. They brought precisely machined, fully interchangeable steel panels. Each panel weighed roughly 600 pounds, heavy but capable of being carried and maneuvered by a six-man team using raw muscle. Working feverishly under the constant threat of German mortar and artillery fire, teams of engineers assembled the steel panels on heavy rollers on the near bank, pinning the massive steel sections together with simple, heavy steel mallets. Because the bridge was designed perfectly for cantilever physics, the engineers simply pushed the skeletal steel nose out over the open water, adding more weighted sections to the rear to prevent it from tipping, until the front of the bridge violently slammed down onto the far shore. A heavy river crossing that German pioneers had spent an entire week carefully wiring with explosives was entirely replaced in less than 8 hours. German forward observers peered through their binoculars in absolute disbelief as endless columns of Sherman tanks simply rolled over the freshly laid steel decking without even shutting off their engines. The tactical delay the Germans had paid in blood to achieve simply evaporated. The natural defensive geography of France was quite literally being paved over in real time. Stripped of their geographical choke points and river defenses, German forces dug deeply into the terrifying terrain of the bocage, the dense, ancient, impenetrable hedgerows of Normandy. Here, at point-blank range, the Wehrmacht's tactical superiority in armor-piercing weaponry was finally expected to bleed the Americans dry. Concealed German infantry wielding shaped-charge Panzerfausts alongside perfectly camouflaged anti-tank guns wreaked absolute havoc on advancing American armored columns trapped in the narrow, sunken dirt lanes. From a purely tactical, unit-to-unit standpoint, the Germans were decisively winning the armored exchanges in the hedgerows. German post-action reports flowing back to Army Group B headquarters in Paris claimed dozens, then hundreds, of American tanks left burning, shattered, and utterly destroyed in the Norman orchards. By the rigid, mathematical rules of military attrition, the American armored division should have been hollowed out within weeks, reduced to nothing more than light infantry support. But to the extreme, maddening frustration of German battalion commanders, the sheer number of American tanks assaulting their lines the following morning never seemed to drop. The Wehrmacht had fundamentally misunderstood the American definition of a destroyed tank. To a German gunner, a penetrated steel hull A blown track and a shattered turret meant a permanent kill. To the United States Army Ordnance Department, it just meant the tank needed a tow. Operating directly behind the frontline combat commands were specialized fleets of M31 and M32 tank recovery vehicles. These were massive, heavily armored wreckers, built on modified tank chassis themselves, equipped with towering A-frame booms, heavy pivoting cranes, and 60,000-pound pulling winches. Under the cover of darkness, or frequently in the middle of an active, chaotic firefight, these heavily armored recovery crews would roll directly into the kill zone, hook thick steel cables to the shattered, smoking hulls of dead Shermans, and drag the 30-ton dead weights out of the mud and back to the rear. They dragged them to mobile ordnance maintenance companies hidden just a few miles behind the front lines. These field workshops were not mere mechanic garages. They were highly organized, heavily equipped mobile factories. Hidden beneath camouflage netting in captured apple orchards, these units were outfitted with heavy diesel generators, blindingly bright arc welders, heavy machine lathes, and massive pre-packaged stockpiles of factory-fresh spare parts. If a German armor-piercing shell had punched cleanly through a Sherman's engine block, American mechanics did not waste time trying to repair the damaged cylinders. They used a heavy crane to violently rip the ruined engine out of the hull, unboxed a factory-fresh Ford V8 or Continental radial engine, and dropped it perfectly into the chassis within hours. They welded thick steel patches directly over the jagged penetration holes, hosed the blood, ash, and debris out of the crew compartment, loaded a fresh complement of high-explosive ammunition, and painted over the scorch marks. A Sherman tank that was brutally knocked out and left for dead on a Tuesday afternoon could easily be back on the firing line, fully fueled and manned by a replacement crew fresh from a depot by Thursday morning. The psychological horror for a German anti-tank crew was profound. They were watching their hard-fought tactical victories erased overnight. They were fighting a war of attrition against a relentless enemy that was actively and systematically recycling its own casualties directly on the battlefield. By late July 1944, the relentless pressure finally broke the German lines. The American First Army shattered the front during Operation Cobra, breaking out of the claustrophobic Normandy hedgerows and pouring into the wide-open French countryside. The static, grinding battle instantly became a high-speed, mechanized pursuit. General George S. Patton's newly activated Third Army began sprinting toward the ports of Brittany and the banks of the Seine. But this extreme, unprecedented velocity created a completely new set of expectations in the minds of the retreating German general staff. They intimately knew the fuel mathematics of a blitzkrieg. A single American armored division consumed upwards of 25,000 gallons of high-octane fuel every single day when on the move. As the Wehrmacht fell back in disarray, they meticulously destroyed the French railway network. They obliterated switching yards, burned massive fuel storage tanks, and destroyed thousands of pieces of rolling stock. The German staff officers retreated with a dark sense of operational confidence. They calculated that the American armored spearheads would soon brutally outrun their own supply lines. You simply cannot feed a mechanized thrust moving 50 miles a day using 5-gallon jerry cans, ferried in trucks from landing beaches located hundreds of miles to the rear. The American tanks would inevitably run out of gas. Their engines would stall in the open fields, and they would become highly vulnerable static pillboxes where they could be surrounded, isolated, and destroyed by German counterattacks. But as the German rear guards retreated, they looked back and realized the Americans were not waiting for the shattered French railways to be rebuilt. The United States Army was literally laying its own arterial system across the continent. Right on the very heels of the advancing frontline infantry, American quartermaster and engineer petroleum distribution companies were unspooling a massive continent-spanning network of flexible 4-inch steel pipelines. This was the inland extension of the massive Operation Pluto, the pipelines under the ocean that had originally pumped fuel across the English Channel. Using specially modified transport trucks that carried miles of lightweight steel piping, American engineers coupled sections of pipe together with highly efficient, flexible Victaulic joints at an astonishing, incomprehensible rate of up to 50 miles a single day. They did not bother burying the pipe. They laid it in roadside ditches, strapped it to the surviving steel girders of Bailey bridges, and ran it straight through the bombed-out ruins of French towns. They quickly set up heavy diesel booster pump stations hidden inside captured barns and French farmhouses, pushing thousands of barrels of high-octane aviation fuel and diesel continuously, 24 hours a day, directly from the Normandy coast to the rapidly shifting front lines. Massive temporary storage depots, featuring giant collapsible rubber fuel tanks holding millions of gallons, seemed to sprout from empty farm fields overnight. The Americans were not just bringing fuel with them, they were constructing a permanent, high-volume industrial plumbing system that physically chased the retreating panzers across the map of Europe. By August, a profound and terrifying psychological shift began to permeate the German officer corps. The private diaries of captured Wehrmacht commanders, combined with highly encrypted radio intercepts analyzed by Allied intelligence, revealed a creeping existential dread taking hold in the German ranks. Their vaunted tactical brilliance, their perfectly executed infantry ambushes in the hedgerows, their technologically superior, heavily armored Tiger tanks, and the lethal, buzzing fire of their MG-42 machine guns were ultimately achieving absolutely nothing. The German officers slowly realized they were no longer fighting a traditional European military formation. They were fighting a rapidly regenerating Hydra. A seasoned German panzer commander could execute a flawless tactical maneuver, completely outflank an American position, destroy 5 American tanks in a brutal firefight, successfully blow the only bridge over a river, and retreat in perfect order to a highly defensible ridgeline. By every metric of traditional military logic, he had won a decisive, textbook victory. But exactly 12 hours later, as the sun came up, the bridge was back. The 5 destroyed tanks had been effortlessly replaced by 10 brand new ones rolling off the transport ships, and an endless, horizon-spanning column of supply trucks was already pouring fresh artillery shells into the valley to bombard his new position. The German High Command finally understood the horrifying reality of their situation. Destroying an American frontline combat unit was utterly meaningless. Behind every single rifleman shivering in a foxhole, and behind every single tank commander peering through a periscope, stood an intricate, unbreakable, hyper-efficient chain of mechanics, welders, truck drivers, engineers, and quartermasters, stretching all the way back across the Atlantic Ocean to the massive, untouched assembly lines of Detroit and the blazing steel mills of Pittsburgh. The German military machine was highly calibrated to inflict devastating casualties on an army. It had absolutely no mechanism, no doctrine, and no weapon capable of inflicting casualties on a supply chain that simply absorbed localized damage and instantly paved over the smoking wreckage. Yet, industrial momentum is a highly dangerous, inherently unstable phenomenon. The American logistical machine had conclusively proved that it could completely neutralize and overwhelm the lethal tactics of the German army. But as the late summer of 1944 drew to a close, this unstoppable, continent-spanning conveyor belt was about to abruptly encounter an enemy it could not simply engineer its way around: its own unprecedented, blinding speed. As the Allied armies wildly accelerated past the liberated streets of Paris and charged relentlessly toward the German border, they began moving significantly faster than even their own pipeline layers, harbor masters, and bridge builders could follow. The invincible system was suddenly stretching to the absolute snapping point, setting the stage for a catastrophic mechanical heart attack. By late August 1944, the American military machine had engineered its way out of every German trap, but it was about to be paralyzed by its own unprecedented success. Following the collapse of the German lines, the Allied armies didn't just advance, they sprinted. General George S. Patton's Third Army and General Courtney Hodges' First Army were tearing across the French countryside at a staggering pace, sometimes covering 50 miles in a single day. But this relentless velocity ripped open a terrifying logistical vacuum. The massive stockpiles of high-octane gasoline, artillery ammunition, and field rations were sitting securely in the bulging Normandy beach depots, while the combat units burning through them were now hundreds of miles away, rapidly approaching the Belgian border and the Seine River. The traditional bridge over this vast distance should have been the French railway network. But in preparation for D-Day, Allied heavy bombers had spent months systematically pulverizing the rail yards to isolate the German defenders. What the bombers missed, the retreating Wehrmacht ruthlessly sabotaged. The tracks were twisted steel, the locomotives were burned, and the switching stations were craters. The newly laid pipelines were continuously pushing fuel inland, but they simply could not be constructed fast enough to chase tanks driving at highway speeds. Inside the German High Command, a sudden, desperate glimmer of hope emerged. The rigid military mathematics they had relied upon since June were finally reasserting themselves. Wehrmacht staff officers tracking the American spearheads realized the offensive was culminating. The American armor was physically outrunning its own umbilical cord. German reconnaissance excitedly reported American columns stalling on the open roads, not from anti-tank fire, but because the engines were literally sputtering and dying from fuel starvation. The unstoppable mechanized Hydra was choking itself to death. If the American tanks stopped completely, the German army could finally regroup, counterattack, and slaughter the paralyzed spearheads. Standard military doctrine offered no rescue. Railway engineers estimated it would take months to rebuild the shattered tracks. The combat commanders had only days before the entire front collapsed into a massive, fuel-starved traffic jam. To save the offensive from dying in the middle of its greatest victory, the Allied command had to completely abandon standard logistical procedure. They needed an immediate stopgap, a reckless, brute force solution that could physically hurl thousands of tons of supplies across a ruined country faster than the tanks could burn it. On August 25, 1944, that brute force solution was unleashed. It was called the Red Ball Express. It was not a carefully orchestrated, elegant military maneuver. It was a massive, continuous, screaming loop of internal combustion and human endurance. To bypass the shattered railways, Allied logisticians commandeered two parallel highway networks stretching from the Normandy beaches deep into the French interior, designating them as strictly one-way, closed-loop routes. Any unauthorized vehicle found on a Red Ball road was forced off the asphalt by military police. Nearly 6,000 standard 2.5-ton cargo trucks were hurled into the system. The convoys ran 24 hours a day, completely ignoring the strict blackout regulations that normally protected vehicles from Luftwaffe strafing. They had to. Blazing headlights were the only way to keep the heavily overloaded trucks from plunging into ravines at 40 miles an hour. But this was not a flawless, gleaming triumph of American engineering. It was a brutal, bone-rattling grind that pushed men and machines well beyond their physical limits. The vast majority of the drivers were African-American quartermaster troops who were given a single, unyielding order: keep the wheels turning at absolutely any cost. They drove for 30, 40, sometimes 50 hours straight. To fight off total physical collapse, they bypassed standard rest stops, swapping seats while the trucks were still moving. One man grabbing the vibrating steering wheel, while his partner crawled into the back to sleep on top of wooden crates packed with high-explosive artillery shells. The mechanical cost was staggering. Engines overheated and seized from the relentless RPMs. Brake linings burned completely through, leaving heavily loaded trucks hurtling down steep French hills with no way to stop. Tires violently blew out on the jagged, shell-pocked asphalt, leading to mangled crashes in the pitch black. Wrecked, smoking trucks were pushed ruthlessly into the ditches by armored bulldozers, so the convoy wouldn't lose a single minute of forward momentum. When drivers ran dangerously low on fuel, they frantically siphoned gas from disabled vehicles abandoned on the roadside. Every single gallon was fought over in an exhausting, desperate struggle against time and friction. Yet, listening to the unending mechanical roar echoing across the French countryside night after night, German intelligence officers realized their mathematical certainty had been shattered for the final time. The American spearheads did not stall. Through sheer willpower and mechanical sacrifice, the Red Ball Express hauled more than 400,000 tons of supplies to the front lines between August 25th and November 16th, 1944. The trucks were literally shaking themselves to pieces, and the drivers were hallucinating from sleep deprivation. But the frontline armor kept moving, permanently breaking the last German hope of a logistical collapse. The sheer, brute force survival of that supply line circles directly back to the fatal miscalculation made on the morning of June 6th. When the German observers peered through the concrete slits of the Atlantic Wall and watched the horizon fill with landing craft, they braced for a traditional clash of arms. They anticipated a fierce, localized battle against soldiers in armor, expecting a war where superior tactics, heavier tanks, and martial discipline would ultimately decide the outcome. What they entirely failed to comprehend was the staggering, invisible industrial apparatus pushing that vanguard forward. Throughout the summer and fall of 1944, the Wehrmacht was forced to learn a brutal, inescapable truth of modern mechanized warfare. German forces could execute brilliant, textbook defensive maneuvers. A single heavy tank could destroy 3 American Shermans in a localized firefight. German pioneers could detonate a vital railway bridge, and artillery batteries could obliterate a forward supply depot. By all the classical rules of European combat, they were inflicting heavy, sometimes devastating tactical damage. Yet, every single time they scored a hit, the victory was erased before the smoke even cleared. New vehicles inexplicably rolled out of the tree lines. Newly constructed roads miraculously appeared over shattered earth. The relentless flow of fuel, ammunition, and replacement parts simply absorbed the blow and paved right over the wreckage. The German military machine was built to fight a war of tactical heroism, where the quality of the individual soldier and the superiority of the weapon reigned supreme. But they were conceptually defeated by relentless, overwhelming industrial scale. The sprawling Allied logistics network proved that individual brilliance on the battlefield is completely meaningless if it cannot be continuously sustained. The ultimate victor in a mechanized conflict is not the army fielding the heaviest tank or the most brilliant tactician, but the army whose supply chain never sleeps. The architects of the Third Reich had poured millions of tons of reinforced concrete to build a formidable Atlantic wall, fully expecting to bleed a conventional invading army to death on the beaches of France. They prepared for a finite, calculated battle of men and armor, strictly governed by the traditional European laws of operational attrition. But as the relentless American supply lines paved over their shattered defenses, the German high command discovered their fatal error entirely too late. Victory did not require merely halting a military force, but physically stopping the mechanical output of an entire industrialized continent.